Okay, so then there are the absolute value inequalities, which takes that whole and or inequality graphing situation and brings it to a whole nother level. So what I'm going to do is um, I'm going to present to you two different problems. Okay, now the first one is this. So we have 3 times the absolute value of x plus 2 is less than, we'll say, 27. Now here's the thing. For these, you cannot, the first thing you got to do is just get this absolute value thing all by itself. You do whatever it takes to make that happen. Now in this case, all that's required to get this absolute value thing by itself is to divide both sides by 3 to get rid of that 3. So we're going to go ahead and do that. And when we do that, we end up with x plus 2 is less than 9. Now I will make a side note. If this was a negative 3 and we divided both sides by negative 3, then we would have to flip this absolute value symbol so it was like that instead. You know what I mean? And you seemed pretty clear on that today. Now, I'm going to present this to you in a way that I'm pretty sure your teacher is presenting to you based off of your notes. Okay? Now, basically what your teacher is saying is when you do get this absolute value all by itself, then you're going to do this thing where you split it up into 2 different equations, or inequalities I should say. The first one is where you have x plus 2, you drop the absolute value symbols and then you preserve everything else. Okay, so notice this is the exact same thing as this, except now we don't have absolute value symbols. Okay, and then for this one, this is an and situation. And the way that we know that is because of what your teacher said, the greater thing. This absolute value is less than 9. It's not greater than 9. If it was greater than 9, then it would be an or situation because of the greater. Okay, but since the x plus 2 in absolute values is less than 9, it's not a greater situation. It's therefore an and situation. And I kind of like that trick of the trade. That's kind of nice. So we know for a fact that it's and. Okay, so we already wrote the first inequality, and now we're going to write the other one. And that's nothing more than writing the x plus 2, but then changing the direction of the inequality, and then writing a negative 9, so changing the sign as well, okay, of the other number. So, we're almost done. You just kind of do them one by one now from this point. I'm going to focus only on this one now. And I'll keep it in blue. This ends up being x is less than 7. And then I'm going to focus on this one. It's x is greater than negative 11. Okay, now your algebra seems pretty strong. So I'm sure you know how I did that. You just subtract 2 from both sides, okay? And then it's still an and situation, right? So you just do what we've done before. In this case, it would be number line. Critical values of 7 and negative 11. Now, I didn't write it, it's not in perfect order, but we're going to start with this negative 11, and we'll keep it in red. Well, actually, not yet. It's a critical value of 11, negative 11. And then we have the critical value of 7. And we'll focus on the negative 11. It's red. And x is everything greater than negative 11, so that's an open circle, and that's an arrow that goes forever this way. And then x is everything less than 7, so that is an open circle above 7 and everything going this way. Alright, now since it's an and situation, you're focusing only on the intersection, and we have an open circle here, open circle there, and the intersection occurs between those 2 points. So that's how you would graph that particular problem. Okay, so I'm going to present to you a different problem that, as you would suspect, is going to end up being an OR problem. And that would be something like this. Imagine you had 3x, 3 times x plus 7 minus 2. And that was greater than, let's see what number would work, 7. Okay, so you're going to want to follow the same steps in that you want to isolate this absolute value first and foremost. Now, before, all we had to do to isolate the absolute value was to divide both sides by 3. But unfortunately, you can't do that here because you have this -2. So a good way to think about it is like an algebra problem. Because remember, this x plus 7 is really like just some number. We could represent it as a. Okay, like the variable a could represent this absolute value. And if we were to think of it that way, then it would be like 3a minus 2 is greater than 7. Well, what do you do when you have 3a minus 2 is greater than 7? Well, you would add 2 to both sides first. That would be the first thing you do. So that's what you're going to do. We're adding 2 to both sides, and then we would end up with 3 times the absolute value of x plus 7 is greater than 9. And then you would go ahead and divide both sides by 3. You'd end up with this. Okay? So you have x plus 7 is greater than 3. Absolute value of x plus 7 is greater than 3. And then at that point, you're just going to do the same thing that you did before. But there is definitely a difference in that now the absolute value is greater than this other number. So, like your teacher was saying, it's that whole greater thing. So we are definitely going to keep in our minds that this is OR. But you're going to want to separate it into those two different equations. The first one, or for two different inequalities, I should say. The first one is x plus 7 is greater than 3. And then we have OR, because we know it's an OR, x plus 7 is less than -3. Then you'd go ahead and just solve both of the inequalities. This ends up being x is greater than -4, and this ends up being x is less than -10. Okay. And since it's an OR situation, we know how to do that. We've got the number line. We've got a -4 and a -10 as the critical values. Now -10 is down here. -4 we'll treat as up here. We can go ahead and do a little color coding action. And we'll start with the -4. So the -4, x is everything greater than that, so it's like an open circle, and it's that way. And then we have x is everything less than -10, so it's an open circle, and it's that way. And since it's an OR, we're dealing with where all the action is. We want to graph where all the action is on the graph. Now there's no action going on in the middle. There's only action going on here and action going on here. So in our final graph, it would be an open circle, darken this area, and then in our final graph, it would be an open circle, darken this area. And that's actually it. Okay, so that's how to handle the absolute value inequalities.